in section 4.1, we talked about various ways to graph quadratics by finding the axis of symmetry and then y-intercept. And in section 4.2, we talked about the solutions of a quadratic, wherever that parabola is crossing the x-axis. So we had four different names for those. One was solutions, one was x-intercepts, one was zeros, and the last one was roots. And what we're going to do in this section is we're actually going to talk about how to factor quadratics in order to find those solutions algebraically. And so we're going to write quadratics in what's called intercept form, which is a factored form of quadratics. So we're going to talk about factored form, and then the book talks about form. I'm going to call it distribution, and this is very helpful right now. So it's going to be a little messy. The reason I don't like using the word FOIL is because if you have something like this, if you're just multiplying two binomials, FOILing is fine. But when we get into chapter 5 and we are multiplying a binomial times a trinomial, FOIL doesn't apply anymore because you can't just do first times first and outer times outer and inner times inner and last times last, because now you have this middle term. So that's why I prefer to just call it distribution and not FOIL. But for the purpose of this chapter, all we will be doing is multiplying binomials by each other, and FOIL does stand for first times first, outer times outer, inner times inner, and then last times last. And when you FOIL, there should always be two terms that you can combine, which would be the inner times inner and the outer times outer will typically be like terms. So if we want to write a quadratic equation in standard form that has roots of -5 and 7, so this quadratic might look like this. It's crossing the x-axis at -5, and it's crossing the x-axis at 7. We don't know what A is in this case, but it might be a quadratic that looks like this, or it might be a quadratic that is going right side up. But it doesn't matter, they just want you to write a quadratic equation. And so when you have a root of x equals -5, you have to think about what factor create that plus 5. And when a quadratic has a root of 7, then the factor that accompanies that is x minus 7. So basically, this is the y equals x plus 5 times x minus 7. Now, if we look at this carefully, it's when we set it equal to 0 that we can find the series of the solutions. So we're basically saying 0 equals x plus 5. What would make this factor -5? You have -5 plus 5 is 0. And then you have 0 minus -12. Called the zero product. So the factors always have to be that is one equation for this particular situation. Now, what if I ask you to find the equation in standard form with this? So -5, that's an easy fact. It's a little bit more difficult. So we're going to work backwards. If we're saying that 1/2 is a solution, and we're trying to figure out the factor that would give that as a solution, think about if we had just solved for x, what was the last step that we did? And the last step that we would have done in this case is divide by 2. And so we're going to work backwards from that. If we multiply by 2, we get 2x minus 1. 2x equals 1. Then we're saying, well, we started with a factor that we set equal to 0. So the last step that I must have done is add 1. So I would subtract 1. This would give me the factor 2x x minus 1 equals 0. This is the factor that we use to prove an x. So this would be our equation. Now that's in factored form. If we want to get this equation in standard form, y squared plus x minus x minus 5. And so y equals 2x squared minus x minus 5. So why don't you pause it now and try and figure out what two factors would give us roots of negative 3/4 and 5. So pause it and try this one on itself, by yourself, and then see what the solution is. So if 5 is root, x minus 5 would be the factor. If negative 3/4 is root, we need to work backwards from there. So the last thing I must have done was divide by 4, so I'm going to multiply by 4. So I get 4x equals negative 3. And then I must have subtracted 3 from both sides, so I'm going to add 3 so that I get it set equal to 0. So 4x plus 3 equals 0 would be the factor that gives you a solution of x equals negative 3/4. And now they want it in standard form, so we need to distribute. So we get y equals 4x squared minus 20x plus 3x minus 15. Combine our like terms, and we get y equals 4x squared minus 17x minus. So zero product property, which is what we've been basing all of this on, states that for any real numbers a and b, if a times b equals 0, then either a equals 0 or b equals 0 or both. And so in factored form, what we're looking at is x plus 3 times x minus 5 equals 0. What values of x would make that 0? This is essentially a, and this is essentially b. And so if x plus 3 is our first factor, what will make that 0? So we're going to set it equal to 0. And x equals negative 3, solution. And for our other factors, we're going to set x equal to 0. So x minus 5 equals 0, so x would equal 5. So our two solutions to this equation would be negative 3 and 5. And every quadratic equation has two solutions because it's a second degree polynomial. So first thing you want to do is factor out your DCF when you're learning how to factor. And so you look at what do these two terms have in common. I can pull out 3y in both of those terms, and when I do, I end up with 3y plus 1. Now it's always a good thing to do at this point to check that to make sure that if you multiply it back out, you haven't changed the value of the equation. So 3y times 3y would give you 9y squared, and 3y times 1 would give you plus 3y. So now let's figure out using 0 product property of this factor. What value of y would make 3y equal to 0? So y equals 0 is one of our solutions. Now we have this factor, so we're going to say 3y plus 1 is 0, 3y equals negative 1, and y equals negative 1/3. So our two solutions are y equals, and you put it in set notation, and in order from least to greatest, y equals negative 1/3, 0. So you guys try number B, pause it, and then you'll see my solution. So I'm going to pull out my greatest common factor. I can pull 5 right out. So let's find it out. A minus 4 equals 0. To check it, it's 5a times a, 5a squared, minus 28. So we haven't changed the value of that left-hand side. So for our first factor, we want to say what value of a is going to make 5 into 0. That's going to be 0. For our second factor, a minus 4, what value of a would make that equal to 0? In this case, a would be 4. So for this one, your solution set would be a can equal 0 or 4. All right, perfect squares and differences of squares. I'm going to teach you how to factor all trinomials in the same way. And the first thing you want to do is get a set equal to 0, and then identify a, b, and c. So in this case, a is equal to 1, b is equal to -6, and c is equal to 9. Now the way the book teaches factoring is you multiply a times c, and in this case, a times c is equal to 1 times 9, which is 9. Now we want to say what b is, and on the other side of the term, we declare that b is -6. So the point of this chart is you're figuring out what multiplies together to give you 9, and what adds together to give you -6. And so we can start by saying, well, what is 9 times 1? Well, 9 times 1 is 9, but 9 plus 1 is 10. That doesn't give us the sum of -6 that we want. So let's say 3 times 3. 3 times 3 equals 9. 3 plus 3 is positive 6, and that doesn't give us the -6 that we want. But we're close. So what if I say -3 times -3? Well, -3 times -3 gives us positive 9, and -3 plus -3 gives us -6. So that is the scenario that we want to use. Now what you're doing is you're taking this -3 and -3, and that's how you're breaking up your linear term. So we're rewriting this equation as x squared minus 3x plus 9 equals 0. I haven't changed the value of that left-hand side at all. All I did was break down this 6 into -3 minus. What happens now is we're going to group the first two terms together. So we're going to group these two terms together, and then we're going to group these two terms together. Now what can I pull out of x squared minus 3x? Okay, this common factor into x becomes x minus 3. Now what can I pull out of the green one, which is -3x plus 9? And I want to make sure that if this first term is negative, I'm going to pull out 3. And when I pull out a -3, it becomes x minus 3 equals 0. Now when you factor this way, these two factors will always match. And so when you look at the purple term, which is this whole thing, and you look at the green term, which is this whole thing, you say, well, what do they have in common? And what they have in common is x minus 3. So we're going to pull x minus 3 out of the purple and out of the green. When we pull that out of the purple, we're left with x out here. And when we pull it out of the green, we're left with minus 3 right here. So it becomes x minus 3 times x minus 3 equals 0. And so what would the solution be to this? Well, we have two factors that are both the same. And so if we just say x minus 3 equals 0, I get the x minus 3. So what you'll find, and what we'll talk about in this chapter, is when you end up with a quadratic equation that essentially becomes x minus 3 quantity squared equals y or equals 0, 3 is considered to be a double root. And we'll be talking about that throughout the chapter because every quadratic factor has a solution. All right, perfect squares and differences in squares. Y squared equals 3. So I'm going to start equal to 0 and say y minus 36. Now, anytime you have a different square, just now square here, and that is y. Oh, and I have a perfect square here. Perfect square. So double bubble. Then you put plus, and then you put your perfect squares here and the other here. These two factors, y plus 6 and y minus 6, are called conjugates of each other, and if you distribute them out, what you'll find is that your middle terms, your outer times outer and inner times inner, is negative 6y plus 6y, and that middle term cancels out. So when we look at the solutions to this, y plus 6 would give us the solution y equals negative 6, y minus 6, that gives us a solution y equals 6. So in this case, y is equal to negative 6 and 6. Okay, why don't you pause it now and try this one on your own. And so what you're going to do is look at the first and the last terms. And so let's say A equals 1, B equals negative 16, and C equals 64. So we're going to make our chart A times C. In this case, A times C is equal to 64, and B is negative 16. Now remember, we want things to add together to give us negative 16, and we want them to multiply together to give us AC. So if I start looking at numbers here, I can say that 4 times 16 gives us 64, but 4 plus 16 gives us 20. I could say negative 16 times 4 gives us positive 20. I could say 8 times 8, that adds together, that multiplies together to be 64, but it adds together to be positive 16. That's negative 8 times negative 8 multiplies together to give us positive 16 and adds together to give us negative 16. That's what we want. So we're going to break up that term into these two numbers. So we're going to write x squared minus 8 plus 64 equals 0. So factor out negative 8 negative 8 plus x minus 8. Now, if you don't have two factors, then something has gone wrong. These two should match up. So when I look at the red and look at the blue, I see that when I say that 4x minus 8 out of the blue, left with minus 8, 0. So again, we have a double root. Now let's factor one that doesn't have square. So identify A equals negative 15. So let's do A times C, which is negative 15, and then B, which is negative 2. So we want to add together to get negative 2. We want to multiply together to get negative 2. Now we can start off by saying 5 times negative 2. That multiplies together to give us negative 2, but it adds together to get a positive 2. So that's negative. I just switch the signs, and if we do negative 5 times 2, then that's be negative 2. So that is the one we want. We're going to break down x squared 5x plus 3 minus 15 is 0. So let's pull out of the red times x minus 5. And now let's pull out of the green and force 3x. So x minus 5 equals 0. So when we look at the red and the green, we see that they have x minus 5. When we pull x minus 5 out of the red, we're left with x, and when we pull x minus 5, we're left with. So that's factored form. Now there are two solutions to this. The blue factor is going to yield x minus 5. It's a factor. Green and red yield x negative 3. So you would give me the solution set x equals negative 3 and 5. And now let's do one that's a little bit harder, where a is no longer 1. So we have a equals 5, b equals 34, together to give us 120, that add together to give us 34. Let's start with the most obvious, which would be 12 times 10. That does equal 120, but it gives us a sum of 42. So that's not going to work. So let's go to something a little bit more obvious. What if we divide that? 24 times 5 equals 120, but that adds up to give us 29. So we're still not at that 4. So what about if we do 30 times 4? And 30 times 4 gives us 120, and it adds up to 34. So that is the one that we want to use. So we're going to break down that middle term into 34. So I'm going to rewrite it down here. 5x squared plus 30x plus 4x, what was C, plus 24 equals 0. And so now let's look at the red terms, and I can multiply that out of both of those, and it becomes x plus 6. And now let's look at the terms, and I can pull out 4 from both of those, and it becomes x plus 6 equals 0. So what can I pull out of the red? I can pull out x plus 6 from both of them. When I pull out x plus 6 from the red, I'm left with 5x, and when I pull it out, 4. So that equals 0. Now I can solve. The green is an easy one. The green is going to be x equals negative 6. This purple one, purple and red, we have to say 5x minus 4 equals 0 plus 4. So subtract 4 from both sides, and you get 5x equals negative 4. Divide by 5, and you get x equals negative 4/5. So our two solutions in this case are x equals negative 6 and negative 4/5. Notice how I'm always writing them in order from least to greatest. Okay, want you pause it and you try this one on your own, and then I'll show you how to factor it. Now notice this is not an equation, so you can't solve it. All you can do is factor it. So identify A, identify B, and identify C. So A times C is negative 12, and B is negative 11. We want it to add together to give us negative 11 and multiply together to give us negative 12. So what if I do negative 4 times 3? That does equal negative 12, but it adds together to give negative 4 plus 3 is negative 1. So that's not it. So let's look at negative 6 times 2. That multiplies together to give us negative 12, but negative 6 plus 2 is negative 4. So that's not it. So let's try negative 12 times 1. That multiplies together to give us negative 12, and it adds together to give us negative 11. So that's what we want to use. So we're going to say 3s squared minus 12x plus x minus 4. So putting the first two terms together, I'm going to pull out 3s, and it becomes x minus 4. Putting the last two terms together, there's nothing that I can pull out of it, so I'm actually going to write it plus 1. X minus 4, just to have a placeholder there. So when I look at the red and I look at the green, they have s minus 4 in common, so s minus 4. When I pull out s minus 4 from the red, I have 3s. So when I pull s minus 4 out of the green, we're left with plus 1. That is all you can do to this because it is only, and that's it. Do the homework from the syllabus.